Yes, good afternoon to all. Am I audible? Screen
Yes,
is visible?
sir.
Okay. So coming to the next point. So up till now we have completed section 1, that is the resultant of coplanar forces, equilibrium of rigid bodies, analysis of pinch-jointed planes, and center of gravity and moment of inertia. Correct? Yes. Then coming to the point, entire section we have completed. Coming to the second section, kinematics of the particles, kinetics of the particles, work energy methods we have completed. Okay, so coming to the last chapter, that is mechanical vibration. Okay, so this chapter is basically deals about the mechanical engineering. Okay, so just you should remember one small part. So this is mechanical engineering. So unit number 8, that is mechanical vibration. So this is having only 2 hours chapter. Okay, and the syllabus is mechanical vibration, basic terminologies. Okay, you are going to learn here, and free and forced vibrations you are going to learn here. Then a resonance and its effects, degrees of freedom. Okay, you are going to learn all these things. And in your, if it is a theory exam, then you are going to get 1 2 mark question or 1 mark question and 1 mark question. Now, as it is your multiple choice question, you may expect 2 to 3 multiple choice questions. Okay? Huh? No, only theory. There is no problem with this chapter. Okay. What is syllabus? Mechanical vibration, basic terminology, free and forced vibration, resonance and its effect, degrees of freedom. These are the main topics you are going to study here. Okay. So just concentrate here. Please don't talk. All the bodies having a mass and elasticity are capable of the producing a vibration. Vibration, do you know in general meaning of vibration? It is continuously oscillating body. Correct? Na? Vibration means it is a continuous oscillation. When it is going to oscillate, when it is given a disturbance to the body. Okay, consider this is one body. Okay, is it visible? Okay. So when this is not subjected to any load, so it will be in the static or equilibrium condition. When you disturb it, it is undergoing a vibration. Okay, that is oscillating. Those oscillations may be free oscillations or forced oscillations. So those oscillations will be called as vibrations. Okay, see all the bodies having mass and elasticity are capable of the producing the vibration. In order to create or in order to produce any vibration, the body should have mass and elasticity. Okay, you know mass already. Each and every particle has its own mass. And what is elasticity? Elasticity is the property of the material. Property of the material. Then the mass is inner property of the body, and elasticity causes the relative motion among its parts. Okay, what this elasticity will do? It will causes relative motion among its parts. Its parts means its particles. When a body particles are displaced by a application of the external force, the internal forces in the form of elastic energy are present in the body. Consider this is a body. Okay, so this body is made up of smaller particles, correct? Okay, when you apply the force from the external, this is external force P. Yeah, so force F. Then each particle which are there inside the body, they are subjected to internal force, because to resist the external force, the internal resisting force is created. Okay, when a body particles are displaced by a application of the external force. This is one particle, this is one particle. This will get displaced when it is experienced by the external force. The internal force in the form of elastic energy means whenever this force will act on the body, this force will create the disturbance to the particle. Okay, but this particle is having a elastic property, so that is resisting the external force, and it is maintaining the its initial condition only. Okay, so that is the elastic energy. Yes, no, it is a kind of rubber. Whenever you give the force externally rubber, it is stretching. After removing, then it will come back to its original position. But now here external force is applying it. It is creating the disturbance to the internal particles. But internal particles are having elastic in nature. Okay, that will resist the external force. Then these forces try to bring the body to its original position. Okay, internal forces are there. So this is bringing the body to its original position. Then at equilibrium position, the whole of the elastic energy is converted into kinetic energy. The body continues to move in the opposite direction because of it. See, as you have seen, this is a body. You have given F force, that is external force. So this F force is resisted by the internal force. If you increase the external force, this internal energy also increases. But the stage will come in which the external force is larger than the internal capacity. At that time, the body is undergoing motion. Okay, see, this is a body. I will give the force on this one. The internal forces will resist the force. If I increase the force, this body will rotate. Okay, it is undergoing the oscillation or vibration. The whole and whatever energy you are giving, the energy is converted into kinetic energy. Okay, whatever you are giving the energy, elastic energy is converted into kinetic energy. The whole of the kinetic energy is again converted into a elastic or strain energy, due to which the body again returns to its equilibrium position. Okay, so whenever you consider this is a body, I will draw the figure here only. Okay, I will give the force on this one. Okay, this body will resist the force. When this force increases, when this force increases, then the beam is going to bend like this. Okay, it is going to bend like this. When this force F is removed, so I will remove entire force. After removing, so when the force reaches the maximum, this is converted into elastic energy is converted into kinetic energy. When you remove this force, then this kinetic energy is really converted into again its elastic energy. The whole kinetic energy is again converted into elastic energy or strain energy, due to which the body again returns to its equilibrium position. In this way, vibratory motion is repeated indefinitely and exchange of energy takes place. Thus, any motion which repeats itself after the interval of the time is called as vibration and or oscillations. Okay, so in order to understand these vibrations or the oscillations, you should know this phenomena. Okay, so what is that phenomena? Whenever a body is consisting of particles, you are giving the external force F. Okay, so this force is creating a disturbance to the internal particles. Internal particles are having elastic energy. Okay, the elastic energy is resisting the external force. As you increase the external force, that elastic energy is converted into kinetic energy. When you remove this external force, that kinetic energy is again converted into elastic energy. Okay, it means when the particle is moving, when you remove the external force, then that moving particle will come back to its original position. This is again repeating. Okay, in any motion which repeats itself after the interval of the time is called as vibration or oscillation. Is it clear, the definition of the vibration?
Yes, sir.
Yes. Okay, write on this statement, all of you. First point. Just a minute. Don't write. Okay, write down. From this one. Okay, समझ में आने का. All the bodies the concept clear होने का है. Vibration the concept. All the bodies having having and elasticity, mass and elasticity are are capable of producing vibration. So this may be the first multiple choice question in your exam. What is that one? In order to create the vibration, dash are the important property, sir, mass and elasticity. Next point. Mass is the inherent property. Mass is the inherent property of the body. Inherent property of the body, and elasticity is elasticity causes relative motion among its parts. Parts are nothing but particles. Next, when a body is particles, when body particles when a body's particles are displaced by the application of external force, comma, the internal force in the form of elastic energy, are present in the body. These forces try to bring the body to its original position. Okay, written.
Yes, sir.
Oh, can I go for next slide? Okay. At equilibrium position. The whole of the elastic energy, is converted into kinetic energy. At equilibrium position, the whole of the elastic energy is converted into kinetic energy, and the body continues to move in the opposite direction because of it. It means because of external force. Next point. The whole of kinetic energy is again converted into elastic energy, or strain energy, strain energy, due to which the body again returns to the equilibrium position to the equilibrium position. Full stop. Next point. In this way, vibratory motion is repeated. Vibratory motion is repeated indefinitely, and exchange of energy takes place. And exchange of energy takes place. Thus, any motion, which repeats itself after an interval of time, is called vibration or oscillation. Vibration or oscillation. Okay, have you written?
Yes, sir.
So this is a simple pendulum. Okay, so when this pendulum gets disturbed, what it will do? It will make it to and fro motion. Okay, so after every equal interval of time, it will be under motion only, oscillating. Okay, so importance of this studying the mechanical vibration. Why to study this one? What is the importance of the mechanical vibration? So just read this one and try to understand this one. What he has written. The structures designed to support the high speed of engines and turbines are subjected to vibration. So in the civil engineering, whenever if you want to plant or if you want to establish any turbine or any engine, you have to establish on the platform, that is civil engineering structure. Okay, as this turbines and high speed engines creates the maximum number of vibrations. Okay, due to the faulty of the design and poor manufacture, there is a unbalanced in the engine, which causes excessive and unpleasant stresses. In case during the design of this engine and turbines, if there is a faulty in the design, then that will create a maximum unexcessive sound and maximum unbalanced unpleasant stresses and vibrations also. So unpleasant stresses in the rotating system because of vibration. When the machine is creating a large number of sound, means what? It is under the vibration only. Okay. The vibration causes rapid wear of the machine parts. What it will create? It will create the wear and tear of the machine. Okay. Such as bearings and gears. Unwanted vibrations may cause loosening of the parts from the machine. Okay, as the vibrations are increasing, okay, this will lose the parts of the machine. Okay, so all the parts of the machine are going to lose because of its improper design or material distribution. The wheels of the locomotive can leave a track due to the excessive vibration. Means whenever there is a railway track, whenever there is a lot of creation of vibrations, because of this improper design, material distribution, the wheels of the locomotive can leave the track due to the excessive vibration, which results in the accident of heavy loss. Okay, as you heard, there is a railway railway accident हो गया. क्यों हो जाते? Because of inaccurate design, because of loss of lot of excessive vibration. For that reason, wheels are going to slip away from the track. In that case, there is a chance of accident of the railway. Then, many buildings, structures, and bridges fall because of vibration. Why they fall? Because of the excessive vibration. If the frequency of the excitation coincides with one of the natural frequency of the system, a condition of the resonance is reached, and dangerously large oscillations may occur, which may result in the mechanical failure of the system. Okay, this point try to understand. I will explain. So whenever you consider any material, this material is under a vibration only. Okay, if I consider this pen, pen is already is under vibration only, but those vibration I cannot see with my naked eye. Okay, there are micro vibrations are there present, but I cannot see them. Okay, so each and every material has its own natural period. Okay, so he's speaking that one only. The natural frequencies. All the bodies are having natural frequencies. So if you give the external frequency, that is nothing but frequency of excitation. Okay, frequency of the excitation. This is external frequency. If this external frequency matches with the natural frequency of the material, then there is a mechanical collapse of the structure. Like if you take the bridge, if you take the structure, okay, there is a collapse of the structure because of the matching of the frequency of the excitation and that of the natural frequency of the structure. If those two will match, then there is a fall. So you have seen bridge. Okay, so I'll ask one simple question. Okay, consider this is a bridge. This is a bridge. Okay, so there is a military camp. There is a military camp. The military person they are running on the bridge. So you might have not experienced it. Always these military people are not allowed on the bridge at a time because they are putting their steps on the at a time. Okay, whatever steps they are putting on the bridge, at that time there is this chance to match this excitation frequency with the natural frequency of the material. If these two matches, then there is a collapse of the bridge takes place. Okay, so if you consider this is one bridge, so if you put your steps, all the 100 people are putting your steps at a time. Okay, if that frequency and the natural frequency of the material matches, then there is a vibration. A lot of vibration will create, and that leads to the mechanical collapse of the structure. Okay, whatever I am trying to tell you, are you getting the point? Okay,
Yes, sir.
same point
Yes,
I
sir.
am going to repeat. He has given in terms of words. Carefully listen it. If the frequency of the excitation is what we are giving externally, that is the frequency, coincides with the means matches with the one of the natural frequencies. This material is having three frequencies. One is, okay, you will study later on. Okay, among one natural frequency is one of the natural frequency of the system means body. Okay, a condition of the resonance is reached. Condition of the resonance is reached and dangerously large oscillation will create. If this large oscillation creates, there is a chances of the mechanical failure. Once these oscillations occurs, which may result in the mechanical failure of the system. Are you getting this sentence? Okay, you try to remember this one. When the structure is going to collapse, when the excitation frequency matches with the one of the natural frequency of the system, then the mechanical collapse will take place or resonance will take place. See, you take the one pipe, hollow pipe. Okay, you blow the air. You listen to some kind of noise. It means whatever frequency you are giving, that frequency and the frequency of the material matches, and it creates a resonant frequency. For that reason only you are getting voice sound. So if you blow very small energy, then you will not listen. If you use a maximum energy, then you will listen that voice. Because when your frequency and the natural frequency of that material matches, then only resonance will take place. Are you getting? Yes.
Yes, sir.
Next. Vibration can be used for useful purposes such as vibration testing equipments, vibratory conveyors, hoppers, sieves, and compactors. Okay, these hoppers are nothing but like this. Okay, like this. Sieves are nothing but so the material आपके घर पे वो sieve use करते हैं ना, so that is compactor nothing but when you come to the civil engineering, there you are going to study all this. So these equipment, testing equipment, vibratory equipments are used in the civil engineering field. Vibration is found very fruitful in mechanical workshops. Yes, there the maximum applications are there. in the workshop, such as improving the efficiency of the machine, casting, forging, welding techniques, okay, and musical instruments, okay, piano, वगैरह, okay, and earthquakes for geological research. So what is the earthquake? This is a kind of energy which is given to the earth. There is a lot of shaking will take place. That shaking is nothing but vibration only. Earthquake is nothing but it is a vibration energy to the earth. Then it is useful for the propagation of the sound also. Thus, undesirable vibrations should be eliminated. Yes, vibrations are useful, but undesirable vibrations are not at all useful. Therefore, undesirable vibration should be eliminated or it is reduced up to a certain extent by the following method. So how to reduce undesirable vibration is by removing the external excitation, if possible. Means whatever excitation frequency we are giving, that should be removed. Because whenever there is a bridge, there is multi-person will be running on the bridge. That should be avoided. Avoid kiya to the excitation frequency is not giving. Hence, that there is no matching of the one of the natural frequency of the system. Then there is no vibration. Or using shock absorber. Yes, in your normal tractor, when you are moving, so there, and when you are sitting on the car, okay, you are going on the same road, where vibrations are more in the car or in the tractor.
Tractor.
So in the tractor there are more. In the car there are less. Why there is less? Because there is a absorber. Whatever vibrations are created in the tractor, same kind of vibrations are created in the car also. But those vibrations are absorbed by the absorber. That is nothing but shock absorbers. See, there is a road. Okay, there is a tractor. Okay, this tractor is producing some vibrations. Okay, there is a car. Okay, this car is also producing some vibrations. But will you experience the same kind of vibrations in the tractor and in the car?
No.
Same experience होता क्या? नहीं ना. In the car, you will feel comfort. Because comfort, why it is comfort? Because there is a shock absorber. Okay, whatever vibrations are there, that vibrations are absorbed by the shock absorber. Okay, hence you feel that there is a no vibration. आपको वो seat में रहता है ना, वो cushion वगैरह, that will absorb. There is a spring and all that will absorb all the vibration. Then dynamic absorbers are there. Resisting system on the proper vibration and oscillator. See, there is a 100-story building. There is a 100-story building. Okay, think that this is a 100-story building. There is a earthquake comes and it hits the building. It creates a vibration. Okay, this building will undergo a vibration. Okay, there is a chance of collision of the building. Then how there is a 100, 200, 300, 500 story building is still existing because of there is a technique that is called absorber, that is called dampers are used in the structure. Dampers are there. These dampers will absorb the earthquake shock vibrations and the building is not subjected to that much of vibration. Are you getting all of you? There the
Yes.
dampers are there in the building. There is a dampers in the vehicle. There is a shock absorber.
Sir,
Now,
dampers means
dampers means this is a kind of structure, means material that is placed in the structure. Okay, that will absorb the vibratory energy or shock energy or earthquake energy. Earthquake क्या करते हैं? That is going to disturb the building, correct? Earthquake force.
Yes, sir.
Okay, whatever your seismic forces are there, that is going to disturb the building. So these dampers will absorb those vibrations and that will not affect a large number of vibrations. Clear?
yes, sir.
Yes, sir.
Yes. Okay. Okay. So these definitions are important. In the vibration, there are some technical terms. These are important for your exam. So first point is periodic motion. So what is periodic motion? A motion which repeats itself after equal interval of time. Consider there is a pendulum. Okay, there is a pendulum. So this pendulum is
Yes, sir.
rotating. Right?
Yes, sir.
So is it only one time it rotates or it is continuously it is under motion? It is continuously under motion. It means it is under periodic motion. What is that periodic motion? A motion which repeats itself after equal interval of time. That is called as periodic motion. Okay, all of you read down definitions. These definitions are important examination point of view. First one is periodic motion. Write it as important. No? जरूरत नहीं. Okay. Next page. Periodic motion. A motion which repeats. A motion which repeats after equal intervals of time. After equal intervals of time. Then next point. Time period. Time period. What is time period? It is the time taken to complete one full cycle. One full cycle. So you might have seen this sinusoidal wave. Okay. So from this point, this is the initial point. It reaches the maximum and it comes to this point. Is it one cycle? No. Again, it is going to the negative direction. Again, it is coming back. So from this point to this point is called it is period. Okay. Time period. This is the time period. So period is time taken to complete the one cycle, one full cycle. Then what is the frequency? So for a unit time, how many number of rotations are taken place per unit time? Either you may take per unit second or per unit minute or 1 hour. But for that particular unit time, how many number of revolutions have taken place? Number of cycles per unit time. Frequency is number of cycles per unit time. Per unit time. See, can you tell me what is the relation between the time period and the frequency? Yes. So frequency is nothing but time taken to complete the one revolution. One revolution to कितना time हो गया? Then frequency is the per unit time को how many revolutions are? So they are inversely proportional to each other. So F is inversely proportional to time. Then amplitude. Next one, amplitude. Yes. Yes, correct. You have studied in your physics and all. Okay. Oscillation chapter tha na? Yes. Okay. Then it's easy for you. Okay, amplitude is maximum displacement. Maximum displacement of a vibrating body. Maximum displacement of a vibrating body from its equilibrium position. From its equilibrium position. Okay, understood? Yes. Next, write down natural frequency. Natural frequency. When no external force, when no external force is acting, when no external force is acting on the system, after removing it, after giving it, when no external force is acting on the system, after giving it an initial displacement, comma, the body vibrates. The body vibrates. The body vibrates. These full stop. These vibrations are called free vibrations. Free vibrations. Free vibration. And their frequency as natural frequency. And their frequency as natural frequency. It is expressed. It is expressed radian per second. Radian per second or hertz or hertz. Okay. So listen. What is natural frequency? So whenever there is a one body is there, material is there. Okay. So initially there is no force is acting on this one. When no external force is acting on the system, after giving it an initial displacement, okay, so I will give some initial displacement. If initially it is not subjected to any external force, I will give some disturbance to this one. After, and I will remove that disturbance. So after removing that disturbance, the body is continuously under vibration. Okay. After initial displacement, the body vibrates. These vibrations are called free vibrations, and the frequency is known as natural frequency of that particular body. It is expressed as radian per second and or hertz. Clear this one, natural frequency? Then fundamental mode of vibration. Fundamental mode of vibration. Fundamental mode of vibration. The fundamental mode of vibration. The fundamental mode of vibration of a system of a system is the mode having the lowest natural frequency. The lowest natural frequency. Okay, what is the fundamental mode of vibration? That is the in the each and every body there are different types of natural frequencies. Okay, among them one is lowest natural frequency. That lowest natural frequency is called as fundamental mode of vibration. So you have to remember this one. Okay, most of the time this will be the question. Okay, the lowest natural frequency is also known as fundamental mode of vibration. Clear? So put this one as a star. Okay. Fundamental mode of vibration is called as lowest natural frequency. Is it clear, all of you?
Yes, sir.
Yes. So next one is simple harmonic motion. Simple harmonic motion. This is also called as SHM. Correct? So in the multiple choice question, he may ask define SHM. That is simple harmonic motion. Can you tell me what is SHM? What you have studied in your vibration chapter 12? So whenever there is a body, it undergoes it's a oscillation, free to and fro motion. Okay, one complete to and one complete fro motion. होने के लिए जो होता है ना path, that entire is called. The motion of a body to and fro about a fixed point is called as simple harmonic motion. What is to and fro? See, this is your natural pendulum. So it goes. Okay, it is to motion. Okay, and again it will come back. It is fro motion. To and fro motion. The motion of a body to and fro about a fixed point. About a fixed point is called simple harmonic motion. Simple harmonic motion. Okay, this motion is periodic. See, this simple harmonic pendulum, it is periodic. Whether is it stopping anywhere? No, it is always it is periodic. Then the motion of a simple pendulum is the simple harmonic in nature. Okay, best example is what? Best example is the motion of the simple pendulum. Pendulum is the best example for the SHM. Okay, in the exam he may ask which one is the best example for the SHM. He is going to ask. He will use the rotation of the earth. He will use the rotation of the pendulum. He will use the rotation of the fan and all. What is the answer? Rotation of the pendulum. Pendulum is an example because it is to and fro motion. Then Periodic means after every same time that should complete one cycle. See, this is going and this is coming back at one time t. After some time, after the time t, again it will come back to that position. Same time only. The time should not differ. If that time is differing, then that is not called as SHM. Yes, your pendulum. Okay, pendulum is rotating. The time is very constant. That is continuous रहता है ना. That is always it is under the oscillation, and that much resistance is neglected. Okay. A body having a simple harmonic motion is represented by the this one diagram. Okay, see, miss हो गया, हाँ, miss हो गया. So this is the simple harmonic motion curve. PPT में यही है, PDF. You'll see. Okay, so next one is damping and resonance. Okay, these are the important points. Okay, what is damping? It is the resistance to the motion of a vibrating body. So I told just now dampers, correct na? Dampers is a material which is kept in the structure which absorbs the vibrations. Okay, I told. So damping is nothing but it is the resistance to the motion. Motion, which type of motion it is? It is of a vibrating body. When the body is vibrating continuously, when you take the damping is the resistance to the motion. So that vibrations they are going to minimize. The vibrations associated with this resistance are known as damped vibrations. After placing the dampers, if there is any vibrations are there, okay, those vibrations are called as damped vibrations, and the effect of those vibrations are very less as compared to the initial vibrations. Initial vibrations are very large vibrations. When you place the dampers, that damper will absorb all the vibrations. And even though if there are vibrations, those are called as damped vibrations. Is it clear? Damped vibration? Okay, right.
Yes.
Write down this statement. Damping. It is the resistance. It is the resistance to the motion. To the motion of a vibrating body. Of a vibrating body. It is the resistance to the motion of a vibrating body. Vibrating body. The vibrations associated with this resistance, the vibrations associated with this resistance are known as damped vibrations. Damped vibrations. Next one is resonance. Okay, already I have explained this resonance. Okay, so it's the same thing only here. See, when the frequency of the external excitation is equal to the natural frequency of the vibrating body, the amplitude of the vibration becomes excessively large. This concept is called as resonance. Correct? Na? Means what? I am giving the external vibration, external force to the body, means external excitation frequency, and the body is also having some natural frequency. If those two will match, then there is a resonance will take place. That is, excessive vibrations will take place. That entire phenomena is called as resonance. Get it on this definition. When the frequency of the external excitation, when the frequency of external excitation is equal to the natural frequency of a vibrating body, natural frequency of a vibrating body, vibrating body, the amplitude of vibration, becomes excessively large, becomes excessively large. This concept is known as resonance. This concept is called as resonance. Are you getting what is damping? What is damped vibrations? What is resonance? Are you getting? Yes or no?
Yes, sir.
Yes, these definitions are important for your exam. Okay. Here in this chapter, you just remember the concept. Okay. So next point is degrees of freedom. Degrees of freedom. Okay. So in general, I will tell the explain. Okay. In general definition. See, there is a point. How many coordinates are required in order to locate this point? Okay. See, there is a line. How many coordinates are required? Okay. X-axis, Y-axis, and Z-axis. Only one is sufficient for the line. Only one is sufficient. If there is a triangle or if there is a rectangle, how many coordinates are required? If it is a plane, two only. If I take there is a cube. Okay. If I will take now a cube is there. Okay. How many coordinates are required in order to locate this one? Oh, three. So it is nothing but this is a 1D diagram. This is 2D diagram. This is 3D diagram. The same way there is a one diagram. Okay, there is a degrees of freedom. It means how many coordinates are required. That is going to explain. Just let's see. The minimum number of independent coordinates required to specify the motion of a system. Okay, the body is under the motion. In order to specify the motion of the body, how many coordinates are required? And those coordinates are independent coordinates. They should not be dependent. They should be independent coordinates system. Or at any instant point is known as degrees of freedom. The definition is important for you. What is the definition? The minimum number of independent coordinates required to specify the motion of a system at any instant. Don't talk. At any instant is known as degrees of freedom of that particular system. In general, it is equal to the number of independent displacements that are possible. That are possible. Then the number of varies from 0 to infinity. 0 to infinity. The 1, 2, or 3 and 3 degrees of freedom of the system are shown in this figure. See, this is a figure. The body is only one body. It is displacing x1 and it is having only 1 degrees of freedom. Right? It means in order to specify this motion, how many degrees of freedom are required? Only 1 degree. Here there are two bodies, M1 and M2. So in order to specify this motion, how many degrees are required? 2 degrees. 2 degrees. Here how many bodies are there? 3 bodies. In order to specify these motion of the bodies, then how many degrees are required? 3 for independent coordinates. Okay. So this should be known. In the exam, what he is going to ask? What is degrees of freedom? He is going to ask. Write down the definition. The minimum number of independent coordinates, the minimum number of independent coordinates required to specify the motion of a system. The motion of a system at any instant. At any instant is known as degrees of freedom. of that system, of the system. This point is important. In general, it is equal to the number of, in general, it is equal to the number of independent displacements that are possible, the number varies from 0 to infinity. You should remember this one. Okay, in the exam he is going to ask for the degrees of freedom. The range is 0 to 1, 1 to infinity, 0 to infinity, all. Answer is 0 to infinity. Okay, so in single degrees of freedom, there is only one independent coordinate to specify the configuration as shown in the figure. Similarly, there are two x1 and s2 for the 2 degrees of freedom. This is x1 and this is x2. And for the third one, x1, x2, x3 are the 3 independent coordinates are required in order to specify the motion of the body. So this is 1 degrees of freedom. Okay, 1 degrees of freedom. This is 2 degrees of freedom. Then this is 3 degrees of freedom. In the exam, he will give any one of the figure. So the degrees of freedom for the figure B is how much? The degrees of freedom for the next figure is how much? The degrees of freedom of the third figure is how much? He is going to ask. Okay, you should remember this. Unitless. Okay, just what is the how many? I have to specify. See, I want to locate the length. For the line, what is there? Line only length is there. I have to locate that in some coordinates. How many coordinates are required? Only x coordinate is, or only one coordinate is sufficient. For the plane figures, in order to locate that plane figures in the coordinate system, how many coordinates are required? So, if there is a solid body, in order to locate that into the coordinate system, how many are required? 3 coordinates. Similarly, the motion of a particular body, I need to specify. Okay, how many coordinates are required? That many degrees of freedom are required. Okay, is it understood, everyone? Okay. जरूरत नहीं. Okay, it is not required. आपको चाहिए तो in case diagram निकाल सकते. Okay, anyway, I will upload this video. 50 can just upload. Okay, so in the this is important. Types of vibration. You have studied what is vibration. Okay, in that vibration there are different types. One is free vibration and forced vibration, linear and non-linear vibration, damped and undamped vibration. Okay, so whatever this pendulum is there, this is free vibration. Okay, so in your cyclone there is a bell. Okay, when you press the bell, there is a sound will come. That is forced vibration. When you remove the force, that will off. Are you getting? The pendulum, once if you give the motion, that is always it is under motion only. Pendulum is the example for the free vibration. Are you getting? Okay.
Yes.
Your bell in your house, there is a bell, doorbell. Okay, when you press the button, then only the bell will ring. When you remove the button, so then that will get off. It means that is which type of vibration? Force. By? Bike wala. And in the cycle also there is a steel ring. That is also called forced vibration. Damped and undamped means okay. I will explain this here. Damped and undamped. See, for your understanding purpose only. So this is one structure and this is one structure. Think that this is a table. This is table. Okay. Think that this is a bunch of books. Okay. Bunch of books. Okay. When you shake this table, whether these books will be stayed as it is? No. Okay. There is a disturbance to the books. Okay. If you again disturb this table, a lot of disturbance, then that set is remains as it is, or if they are going to collapse. Okay. These books will get false. Okay. So in order to avoid that one, I will place some dampers here. Whatever vibrations I am giving, those vibrations are absorbed by this damper, and as a result, this whatever tracker is there, that is not subject to that much of vibrations which created this one. Think that this is this is 10 vibrations are produced. This damper will absorb almost 8 vibrations, and it is releasing only 2 vibrations too. That is not affected that much. If there is no dampers, then this bunch of books is also experiencing a 10 vibrations. Are you getting? That is called as undamped vibration. If there is a dampers are there, then that is called as the dampers will absorb the maximum number of vibrations, and it is giving only minor vibrations. That is called as damped vibration. Are you getting all of you?
Yes, sir.
So what is free vibration and what is forced vibration? The definitions are important for you. Okay. In the free vibration, after disturbing the system, the external excitation is removed. External excitation is removed. Then the system vibrates by its own. This type of vibration is known as free vibration. Example, simple pendulum is the one of the best example. Okay, so think that there is only initially it is there, simple pendulum. So you just disturb it. You just give the initial energy. Okay, after remove the energy, this simple pendulum is always under to and fro motion. Okay, it is always in the motion only. This is the best example for the free vibration. One more. So this is a fixed point. This is a fixed point. In between there is a elastic rubber. You initially stretch the elastic rubber and leave it. So it is always it is under a vibrating. So this is also an example for the free vibration. Initially we are giving, and afterwards we are removing. Continuously we are not giving the energy forces. Okay, so that is an example for the free vibration. Then what is the forced vibration? The vibration which is under the influence of the external force is called as forced vibration. Machine tools, electric bells are the best example for the forced vibration. Have you seen this one? Cradle. Okay. So when you give the force continuously, at that time the cradle is under motion. When you remove that one, then it will slowly it is going to reduce its vibration. This is an example for the forced vibration. Yeah. Initially you are giving, that is under vibration only. That is free vibration. Constantly it is under moving only. After some time it is going to reduce. Okay, here also you are giving the energy, and when you remove after 2-3 seconds, it is going to reduce. But for the electrical buzzer and all machine, when you press, that is giving. When you remove, that is off. Instant show and instant off. That is the forced one. But for the pendulum, initially you will go. It is under instant motion. Are you getting the differences between the free and forced? So this is important. Damping. What is the free damp, undamped, okay, and degrees of freedom and free and forced vibration. Only these definitions are important for your exam. Okay, write down this definition. Free vibration and free vibration. First one, free vibration. After disturbing the system, the external excitation is removed. What is that external excitation? Whatever energy we are giving, external energy, okay, that is removed. Best example there. Aditya, okay, external excitation is removed. Then the system vibrates on its own. System vibrates on its own. This type of vibration is known as free vibration. Free vibration. Example, simple pendulum. Simple pendulum. Now the fan is rotating. Which type of vibration it is? That is now it is forced. Okay, if you switch off the fan button, then that will go off. Then that is a force. Okay. Next one is forced vibration. Forced vibration. The vibration which is under the vibration which is under
एग्जाम्पल कैसा फोर्स है?
क्या बोले?
फैन का एग्जाम्पल कौन सा वाइब्रेशन है?
That is free forced vibration, no? See, when you switch off the fan, then that is going to turn off. Huh? Whether is it under motion only? अभी जो मैंने जैसे फोर्स दिया था ना इलेक्ट्रिकल एनर्जी, तभी वो फुल स्पीड में था, मैंने इलेक्ट्रिकल ऑफ करते, दैट इज अगेन रिड्यूसिंग, नो? दैट इज नथिंग बट योर फोर्स वाइब्रेशन.
और फिर बेल, डोरबेल.
डोरबेल इज आल्सो फोर्स वाइब्रेशन.
यस.
जैसे रिमूव करते हैं बटन, देन दैट इज गोइंग टू ऑफ. टाइम हो क्या? इन बिटवीन टास्क नहीं कर इधर है. Okay, so the vibration which is under the influence of external force is called as forced vibration. Forced vibration. Read the example: machine tools, electric bells, electric bells, electric bell. Example. Okay, is it clear? Okay, so in your 2 marks or 3 marks, he will ask the what is the difference between the free vibration and forced vibration. Differences he going to. So just look at this one. In the free vibration, free vibrations are produced when a body is disturbed from its equilibrium position and released. Okay, initially body is here, initially it is disturbed and this disturbance is removed. Okay, this is the free vibration. And in the forced vibrations are produced by an external periodic force. Means that force should be continuous रहने का. जब तक force रहते तब तक vibrations are present. Then second one is the frequency of free vibrations depends on the body and is called as natural frequency. And in the frequency of the forced vibration is equal to that of the external periodic force. How much force we are giving externally, that much frequency is producing from the system. The energy of the body remains constant only in the absence of the friction or air resistance, etc. Means whatever the friction, the energy of the body remains constant in the absence of friction or air. So air friction and your friction is not considered. In that case, the system energy is constant. But coming to the forced vibration, the energy of the body is maintained constant by the external periodic force. Okay, so these are some of the difference between the free and forced vibration. See again, there is one more chart. So in the offline paper, so for 3 to 4 marks it is asked. Write the differences between the free vibration and forced vibration. Just read this one, so you can get a clear idea. So in the first one, free vibrations are oscillations in which a body or system oscillates with its own natural frequency without being acted upon by the external force. Okay, so it means in the free vibration, always the material is under vibration by its own. In the forced oscillation, the oscillation in which the body oscillates with a frequency other than its natural frequency under the influence of the external periodic force. Then second one, they occur due to the elastic force and inertia of the system. And forced vibrations, they occur due to the action of a periodic force applied externally. Whatever externally we are giving the force, it depends on that force. Then free oscillations diminish gradually due to the resisting forces called damping forces. Yes, whenever you are placing the dampers in the system, that dampers are going to absorb the frequency vibration. Hence, your free oscillations are going to nullify, going to minimize. See, free oscillations diminish means minimize or decrease or vanishes or nullify, diminish gradually due to the resisting forces called damping force. Then in the forced vibration persist as long as the body is acted upon the external. Okay, these forced vibrations are there. कब तक जब तक रहे वो जब तक अपने external force देते हैं तब तक. Next, the frequency depends on the mass and elasticity of the body. Okay. Here, the frequency is equal to the frequency of the periodic force applied to the body. Here, the mass and elasticity of the body, self body in the free vibration. In the forced vibration, that is frequency of the external force, what we are giving to the body. It depends on that. Example for the both conditions. For example, when you push a swing, just once it oscillates its own natural frequency. So it is an example for the free oscillation. So when you coming to the, if you wish push a swing, each time slow down, it will continue a swing because of the external force. Means when you want to open the door, you give the force, it will get open. You release and it will come back. Again, if you want to open, you have to give the force. This kind of force vibration. Just you should remember what is the difference between these two. Maximum what he is going to ask, what is the definition and what is the example. In the exam, he is going to give yes, simple pendulum is an example of free or force, or both or none. Free. Okay, electric bulb. No, see, maximum actually it is not it is rotating, but vibrating means when you turn off your fan button, it is going to reduce drastically. Okay, so in the free vibration, the vibrations are continuously there. After larger time, it is going to reduce. Okay, damped and undamped vibration. In the damped and undamped vibration, if the vibrating system has a damper, the motion of the system will be opposed by it. The energy of the system will be dissipated by the friction. In the friction, okay. When the dampers are present, that will absorb the vibrating energy. Okay, that will dissipate the friction. This type of vibration is called as damped vibration. On the contrary, the system having no damper is called as undamped vibration. What is the difference between the damping and undamping? Are you getting? In the damped vibration, the dampers are present that will reduce the vibration. In the undamped vibrations, the dampers are not present and the vibrations are as it is. Read on the definition. All of you read on this definition. If the free vibratory system, if the free vibratory system has a damper, if the free vibratory system has a damper, the motion of the system will be opposed. The motion of the system will be opposed by it. And the energy of the system will be dissipated in the friction. Will be dissipated in the friction. This type of vibration is called as damped vibration. This type of vibration is called as damped vibration. Next point. On the contrary means on the other side. On the contrary, the system having no damper, is known as undamped vibration. Undamped vibration. So in the example, you may ask, the dampers are present in undamped vibration or damped vibration? Dampers are present in damped vibration. Have you written?
No, sir. 1 minute.
Okay. Yes. Yes. Please.
Come.
Okay, completed. Okay. Fine. Yes. Now resonance. Yes. Don't talk. What is that resonance? Already I told. What is that resonance? When the external excitation frequency matches the natural frequency of the system, then the process is called as resonance. See, you are having a tuning fork. Science में study किया था. With that tuning fork, you can collapse the bridge. You can collapse. Once, okay, you will go and hit the bridge. Okay, in the entire bridge, there is a one point. Okay, at that point, your frequency of excitation, tuning fork frequency, and the frequency of the bridge matches at that point, then the entire bridge is going to collapse. For that reason only, the military persons are not allowed on the bridge, because all the people are putting their steps exactly on the point. When they put exactly on the point, if at all that matches frequency of their foot and frequency of the bridge, then the bridge is going to collapse. Okay, if you are only tuning fork, with the help of tuning fork, you can be entirely, you can collapse the bridge. See, that's why always you have to take care. See, what is that resonance? When the frequency of the external excitation is equal to the natural frequency of the vibrating body, the amplitude of the vibration becomes excessively large. Okay, then this concept is known as resonance. The mechanical resonance is a tendency of the mechanical system to respond a greater amplitude when the frequency of its oscillation matches the system natural frequency of the vibration. Okay, whenever there is a mechanical body is there, that is under a vibration only. When this vibration and your that is externally exciting frequency, if that matches, at that time the frequency is very large. That creates a resonance. It may cause violent swaying motion and potentially failure of the improperly constructed structure, including bridges, buildings, and airlines. So always we have to note that the vibration should be minimized. If those vibrations are maximized, as the entire structure is going to collapse. Either it may be building, either it may be bridges, either it may be aeroplanes, either it may be your aircraft or any of the machines. That's why it is very, very important. This phenomenon is known as resonance disaster. Okay. So how to avoid the resonant disaster? Are you getting what is the resonant disaster? Resonant frequency is matching. As the matches, then that is giving a large amplitude, means large vibration. That large vibration leads to the collapse or the failure of the mechanical failure. So how to reduce, how to avoid the resonant disaster? Yes, listen. Okay, see here. Avoiding the resonance disaster is a major concern in every building, tower, bridge construction of the project. The structure is designed to resonate at a frequency which does not typically occur. Okay, we have to design a structure in such a way that typically not occur. Means resonance should not occur in the future. Building in the seismic zones are often constructed to take a note on account of oscillating the frequencies of expected ground motion. Okay, whenever you consider any building, okay, in the ground, what are these seismic waves are there, where they come and attack. They come and attack at the foundation level or at the top of the building. At the seismic waves are generated at the earth, no? That will come and attack to the foundation. Okay, we have to place that proper design steps should be taken at the foundation level. Okay, or substructure to superstructure in between there only. Okay, so whenever you are taking care, whenever you are placing the dampers, those vibrations are minimized. So buildings in the seismic zones are often constructed to take account of oscillating frequency of expected ground motion. हाँ? Seismic waves और earthquake waves. Earthquake को क्या बोलते हैं? Seismic बोलते हैं. हाँ, seismic. Earthquake को. Engineers designing objects having the engines must ensure that mechanical resonance frequencies of the component part do not match the driving vibration frequency. So whenever there is a mechanical component is there, whenever you are oscillating or you are using, your energy should not match with that frequency. Your frequency should not match with that frequency. Such a way that it has to be designed. I say design किया है तो you can avoid the resonant disaster. Okay, see the collapse of this structure. Bridges collapsed because of the vibration. Okay, see the bridge has collapsed because of the vibration. B, see the structure has collapsed because of vibration. क्या? Corrosion का? This is because of your vibration. So इसके लिए in order to avoid vibrations should not pass to the building. So avoid करने के लिए we are having recent technology. Earthquake resisting systems are there. Okay, nowadays when you are coming for the higher studies, there is one chapter, one subject, earthquake resisting structures. Okay, you are studying in the MTech. Okay, their moment resisting frames are there. Okay, there are different technology, recent technologies are there. Those technologies are including in the high-rise structures where there is a 100-story building, there is a 200, 300, 500-story building. Okay, in the Mumbai and all, there is a seismic waves are there, earthquakes. So those structures should not collapse. Okay, our motto is what? They have to retain longer waves. Okay, so in that buildings we are using the recent technologies, okay, that will avoid such a kind of failure. Then parts of the vibrating system. What are the different parts? You should know. Vibrating system basically consists of three elements, namely mass, spring, and damper. Huh? You are not written. Resonant disaster. Okay, I will share this PPT. In a vibrating body, there is the exchange of energy from one form to another form. See, hello. So whenever the body is under vibration, it means the energy is exchanged from the potential energy to the kinetic to the potential. Okay, vibrating body, there is a exchange of energy from one form to another form. Energy is stored by the mass in the form of kinetic energy. What is the formula? Kinetic energy of mv square. Spring, if you consider the spring in the form of potential energy. Okay, when you consider the bodies are under oscillating, that is kinetic energy half mv square ho gaya. You take the spring. In the spring, when you compress it, the kinetic energy is stored in the form of potential energy. Then that energy is nothing but half k into x. The k is the spring constant. X is the how much distance you have compressed from the initial to the again you are compressing how much distance you are compressed, and dissipated in the form of damper from heat energy which opposes the motion of the system. Okay, so that is three components: inertia, that is stores the kinetic energy of mass m; elasticity stores the potential energy spring k; and energy dissipation damper c. Okay, just don't worry all these things. So what all you have to remember? What is vibration? Free vibration, force vibration, damped, undamped, and those technical terms. Okay. Okay. But technical terms you have to remember. Okay. See what is there in your syllabus? Mechanical vibration. Basic terminologies are important. Free and forced vibration. Resonance concept should be clear. Then its effect, degrees of freedom. Okay. So this completes the chapter of mechanical vibration. Yes. Do you have any doubt?
Degree of freedom, repeat correct.
Degrees of freedom. Okay. Wait 1 minute. I will repeat the degrees of freedom. Is this white screen visible? Okay. Think that there is a one point. How many coordinates are required in order to locate this one? I don't want any coordinates. A point. Is there any mass? Is there any movement? No. It is. I don't want any coordinate. Think that there is a line. How many coordinates are required in order to locate this its position? Only one. Okay, along x direction or y direction or z direction. Any one coordinates are sufficient to denote its length. Only length is there. I will take one plane. Okay, I will take one rectangle. So how many parameters are there? How many parameters are there? Two parameters. What are those? One is length, one more is breadth. In order to locate these two parameters, how many coordinates are required? Two coordinates? Yes or no? One is horizontal and one more is vertical. Two coordinates. And for the line, there is only one. Suppose if I take one more figure. So this is a cube, correct? How many parameters are required in order to locate this one in your system? Three are required. Is this correct?
Yes, sir.
What are those? Along x-axis, one is required. Okay, you can take x-axis is required, and there is I want one is y-axis is required, and I want one more along the z-axis. Along z-axis, or if you want to. Okay. So this is x is required, this is y is required, and one more is required, that is along z-axis. Okay, these three axes are required for the distance. Similarly, when you consider any body, okay, when you consider this is a body, okay, I want to locate its vibration. Think that this body is vibrating. Okay, think that this is vibrating continuously. It is under to and fro motion. The mass is only one mass. How many displacement it is giving? It is giving only one displacement. So this is only 1 degrees of freedom. 1 degrees of freedom. Because it is having only one displacement. So what is the degrees of freedom? Independent displacement, independent coordinate system. Okay, if we consider there is a one body and it is connected by another body. Okay, so I will take in the vertical direction. I will take this is one body and connected with another body. Okay, I will give the vibrations from the ground. This body is undergoing some vibrations, distance x. This body is also undergoing another vibration. I will take this is x1, this is x2. How many degrees of freedoms are required? Independent degrees of freedom. 2 degrees of freedom. 2 degrees. If I consider one more, so this is one body, this is one body, and this is one body. Okay, I am giving the forces from the initial. Okay, so this is one, this is one. So this is x1, x2, and x3. Okay, how many degrees of freedom are required in order to locate its freedom? That is 3. 3 degrees of freedom. Are you getting?
Yes, sir.
Whenever body is under vibration, in order to specify its location, its vibration, how many independent coordinates are required? That is called as degrees of freedom. If it requires only one, then it is called as 1 degrees of freedom. If it requires two, then it is called as 2 degrees of freedom. If it is a multiple, then you can call multiple degrees of freedom. What is the range of the degrees of freedom? That is 0 to infinity. Okay, you should remember this. Is it clear, everyone? Yes, this completes all the chapters from chapter number 1 to chapter number 8. I have uploaded some of the important important multiple choice questions. Okay, in your teaching diary. That one is remaining. See, here I have uploaded the MCQ questions. Assignment 9. Only you can write 1 to 7 assignments. See, yes, just listen it. I will read this. Is it visible, all of you?
Yes,
Multiple choice. How the questions are asked in your exams? A body is said to be under free vibration when, first option, there is a reduction in the amplitude after every cycle. of the vibration. After every cycle, whether it is reducing in the free vibration, no, it is a constant only. No external force acts on the body after giving it an initial displacement. Yes, this is the correct definition for the free vibration. Correct? Huh? Then third option is a body vibrates under the influence of the external force. Is it correct? No. So answer is B is correct. Then longitudinal vibrations are said to occur when the particle is moves in which direction? Longitudinal vibration perpendicular to the axis, parallel to the axis, circle is it about the circle axis. Okay, see, I will clear this concept. Longitudinal vibrations. Consider this is one body. Okay, so this is one plate. Longitudinal vibrations means the vibrations are parallel to each other. Okay, it means perpendicular to the axis. Vibrations are perpendicular vibration. मतलब ऐसा होता क्या body parallel means it should be like this only. It should be like this only. It is parallel to its axis. Is correct. Okay. Then transverse vibrations are said to occur when the particles are about a perpendicular. Transverse means perpendicular to the axis. Then when there is a reduction in the amplitude over every cycle of the vibration, then the body is said to be free vibration, forced vibration, damped vibration, undamped. The amplitude is reducing. Reducing means it is damped. Dampers are absorbing the vibration. Then the acceleration of a particle moving with a simple harmonic motion. Yes, what is the acceleration? It is simple harmonic motion. It is velocity is constant. As the velocity is constant, what is acceleration?
Zero.
Rate of change of acceleration velocity is nothing but concentration. As the velocity is constant, dx differentiation of constant is zero. Acceleration is zero. Are you getting?
Yes, sir.
Yes. Sixth one. The maximum velocity of a particle moving with a simple harmonic motion, that is omega into r. Then torsional vibrations are said to occur when the particles of a body move in a perpendicular axis, parallel axis, in a circular about its axis, in none of this. See, torsional vibrations are nothing but see here. Hello, there is a spring. Okay, when you give this vibration to this one, all the springs are under vibration only. Means all the vibrations are in circular manner. Okay, so all the vibrations are circular manner. Then those vibrations are called as torsional vibrations. Okay, so these torsional vibrations are said to occur when particle moves in a circle about its axis. Are you getting answer? All of you?
Yes, sir.
Yes. Then acceleration of the particle, moving particle with its SHM moment at any instant is given by W square into S. It is as good as your angular velocity, angular acceleration. Then frequency of vibration is usually expressed number of cycles per second or radian per second. A rigid body possesses dash degrees of freedom. This is one. A rigid body produces 6 degrees of freedom. Okay, so 1, 2, 4, and 6. You remember this one. 6 is along x, y, z, and again the displacements are there. Along each axis, there are two. Okay. Okay. What are those? I will tell this. 6 कैसे हो गया? So there are some examples. For that example, only 1 degree of freedom is there. And second example, there is only 2, 4, up to 6 is there. For the rigid body, there are 6 degrees of freedom. See, for this reason only you have to study the multiple choice question. In the exam, he is going to ask the same question. But if you don't know the answer, then you usually say it is out of syllabus. It is not out of syllabus. Huh? The body is said to be under forced vibration. When it is forced vibration, there is a reduction in the amplitude after every cycle of vibration. No external force is acting. A body vibrates under the influence of external force. None. Which one is the correct? C is the correct answer. See, this black letter, bold, it is not a correct answer. Okay, don't depend blindly on the answer. There is a reduction in the amplitude. In the force vibration, is there any reduction? No, there is no reduction. So there is a body vibrates under the influence of the external force. That is called as force vibration. Okay, C is the correct answer. You should remember, this is the correct answer. Then, the danger of the breakage of vibration means what? Yes, the danger of breakage and vibration is maximum below the critical, near the critical, above the critical, none of the above. Danger of the breakage. Okay, breakage, it has not broken, it is going to break. It is near, okay, near the critical speed. The velocity of a body moving with a simple harmonic motion, yes, that is maximum. Okay, harmonic motion is more, it is to and fro motion. It is not reducing, it is not increasing, it is the maximum constant. Huh? Mean means it's a mean. Okay, you can consider one position. Okay, at that point it is constant only. You can start mean in the sense this is a starting point. Okay, this will be starting. It will go here. It is least, and here it comes. It is the maximum, and here it will go. It is the least, and again it will come back to its original position. Here is the maximum. Mean means starting point. It is maximum. The amplitude of vibrations is always dash the radius of the circle equal to equal. Okay, number of amplitude of the vibration is always equal to the radius of the circle. Then the acceleration of the particle moving with a SHM is inversely proportional to the displacement of the particle. Yes, is it correct? Acceleration he is asking. Acceleration. नहीं होता ना. So there is no. Okay, no. Acceleration is not happening in the SHM. Are you getting? Is there any acceleration in the SHM? In the simple harmonic motion, there is no acceleration. The velocity is constant. As the velocity is constant, acceleration is zero. As the acceleration is zero, then there is no case of dependency between the acceleration and displacement. Then the resistance to the motion of a body is called as medium of vibration, speed of vibration, length of vibration, external friction. Medium of vibration. It is the resistance of the motion of the body. So the body is vibrating. Okay. So in order to reduce this one, a medium is required. Okay, that is medium of vibration. Best example is your damper. Damper is the medium of the vibration. Okay, it is going to reduce resistance of the motion. Correct? Are you getting all of you?
Yes, sir.
In which direction does the damping force act? Damping force opposite to the motion. Okay, it means, see, your building is there. Okay, building is there. Okay, this is the foundation. Your seismic waves will come and attack to the foundation. That energy is transferred in the opposite direction. You are placing the dampers here. That is giving resistance in the opposite direction. Means that is reducing in the opposite direction. This is opposite to the motion. Correct. Next, which instrument is used to record the building vibration or vibrations of a huge structure like railway bridges? Yes. Stroboscope, accelerometer, vibrometer, and none of the above. So, accelerometer, it is a kind of instrument which is measuring the acceleration. Mechanical instrument. There is the odometer. You don't know, but there is a odometer. Odometer is like this. Okay. See, this is starting stage of the road. You have constructed the road like this. Okay, here. It is very difficult to measure this one. So in this odometer, there is a measurement. How many revolutions are taking? If it covers one revolution, then it counts one. Two, then two. So person, what he will do? He will take his vehicle and he will start from this one. He will move one round exactly. Okay. He will not. He is not going to measure this one. Just he will take the initial count. Initially count is how much count. Then he will come to this point. Okay. How much is the count now? So final count minus initial count you will do. You will get the how many revolutions has taken place. That many revolution into that circumference will do. That is going to be the total length of the road. That is the odometer. Similarly, there is a vibrometer. Means vibrations are creating. What is the frequency of the vibration? That is going to measure. Then the vibration in a vehicle is normally expressed in terms of vibrations are displacement, velocity, acceleration, and none. See, vibrations are coming very fast. Okay, these are measured in the acceleration. Okay, in the vehicle it is in the vehicle. See, is it a constant? Vibrations are constant. Simple harmonic motion is a constant, but these vibrations, specific waves, they will when that will come, we don't know. It will come and attack and it will go. Very high acceleration. Then number of cycles described in 1 second. In 1 second, how many number of cycles are completed? That is the frequency. Then what is the period? What is the period? Time required to complete one cycle is called as period. A certain amount of energy possessed by the vibrating system is always dissipated, overcoming the dash to the motion. That is frictional resistance, fluid resistance, thermal resistance, all. Means in order to overcome the initial stage, some initial energy is required. That is nothing but your frictional energy. For the free force, free vibration, in order to create the free vibration, initial energy you have to do, correct? In order to create the free vibration, initial energy you have to give, correct? No? So why you have to give? In order to overcome the frictional resistance. Then, which among the following is a type of free vibration? Longitudinal vibration, transverse, torsional, all are the anyone may be all are. When there is a reduction in the amplitude over every cycle of vibration, then the body is under damper vibration. Amplitude is reducing. Then, when the particles on the shaft or a disc moves approximately perpendicular to the axis of the shaft, then the vibrations are known as perpendicular to the shaft. It is nothing but transverse vibration. Along the axis, parallel vibration. Along the circular path, that is circular vibration. When the particle of the shaft or the disc move in the circle about the axis of the shaft, it is called as torsional vibration. In the circular manner, if it is moving, that is torsional. Then, when the body vibrates under the influence of the external force, then that is called as force vibration. Okay. Okay. These are the additional MCQ. In order to double the period of the SHM, the length of the string is quadrupled. Means there is a relation between the length and period. Length and period. Okay, that is under root of L is equal to under root of T. In order to increase double करना है तो इधर quadruple करना. Okay, that is there. See the periodic time of one of the oscillation. This is the periodic time. 2 pi root L by G. This is the formula for the periodic motion. क्या? 2 pi by 2 omega. ऐसे है क्या? 2 pi by I don't know that. If the damping factor of a vibrating system is unity, then the system will be critically damped. Actually, these are the important MCQ of the earthquake resisting force. Okay, so it may ask, but these are acceleration of the particle at an instant has the two components, radial component and tangential component. These two components will be perpendicular to each other. So in your rotating body, you have seen. See, in the circular motion, there are two components. One is tangential velocity and one more along this one. So these two are perpendicular to each other. In which type of vibration, the amplitude of the vibration goes on decreasing. Vibrations are goes on decreasing. In the damper vibration. Which type of vibrations are also known as transient vibration? Same, damper vibration. From the following, which one is the type of vibration measuring instrument? That is mechanical, electrical, magnetic, all of the above are vibrations measuring instrument. Magnetic vibrations are there. So if you have magnet, okay. If you have magnet, so from that magnet also there is a vibration. When a body is subjected to longitudinal vibrations, the stress induced in the body is shear stress, tensile stress, compressive. See, actually, these are the higher level for my MCQs. Whatever the red questions are, red colors are there. Higher level multiple choice questions. Okay, you study all those ones. Previous black colors. So these are all are higher level. When a body is subjected to transverse vibration, the stress induced in the body is shear, tensile, compressive stress, bending. You don't know what is shear stress, what is tensile stress, what is compressive, what is. These will study you study in the second year, in the strength of material subject. Okay. Here it is bending. Okay, don't worry about all this. Okay. So these all are the multiple choice questions. Okay. So this completes all the multiple choice questions of all the chapters and as per the syllabus. Yes. Now, if you have any doubt, you can ask me. Yes. Is there any doubt? किसी को doubt है क्या? Yes, you can. I have uploaded the assignment number 6 and 7. Okay, and you please try to solve those two assignments and submit it. So I'm going to check all your 1 to 7 assignments. Okay, and I'm going to finalize your marks also. Okay.
सर अलग अलग लिखना है क्या?
अभी कैसे लिखा है? असाइनमेंट 1, असाइनमेंट 2 एक ही नोटबुक
हाँ
में
सर
लिखा है
वैसा
ना?
लिखा है.
हाँ,
लास्ट वाला सर
ऐसे-
आपने दोनों
हाँ
एक एक लिखना है सर.
नहीं नहीं 7 भी लिखने का है, 8 भी लिखने का है. सॉरी 6 and 7 दोनों लिखने का है. असाइनमेंट 1, 2, 3 किया कैसे किया? पेजेस में लिखा है क्या और कैसे किया? नोटबुक में लिखा है. Notebook. Okay. So write these 2 assignments and submit online. Those who are there in the online. If the people are here only in the offline, then you can submit it towards me. So I will check your assignment and I will hand over your assignment. Okay. Just I will take the attendance now. Seven. Roll number 7. 9, 10, 11, 13, 15, 16, 20, 25, 27, 29, 30, 35, 38, 38, 52 present, 53, 57, 61, 62, 62. 57 is present. Rohan Shinde. Okay, absent numbers 7, 13, 16, 25, 27, 38, 53, 62. 25 present. Yes, 25 present. Okay, so now I will stop. So if you have any doubt at any point of time, you can call and you can do the message, or you can come to the college, you can show it to me. If you have any doubt, you can discuss with me. Okay, so from my side I have given 100%. Now it's your turn to put your effort. Okay, whatever, don't refer this book, that notes, and whatever notes I have given, I have dictated, I have taken lot of, I have solved so many problems. You please go through those problems only, and only don't depend on those MCQs or those problems. You solve all the problems and solve all the MCQs. In the exam, you may expect the same problems. Okay, at that time, what you have to do? You have to solve by your own. Okay, answers याद रखने का जरूरत नहीं. You have to solve your own and you have to solve. See, there is a resultant of एक diagram देते हैं उन्होंने. तो याद रखने की जरूरत नहीं. So you should know sigma x and sigma fy. Then resultant you can find out. Correct ना? And some of the concept, like in the friction there is a concept. Okay, in the beams there is a concept. Hinged, okay, fixed, simple, how many reactions. In the kinematics, motion of lift. In the vibrations, free vibration, damped, undamped, or in technical terms, in the projectile of the motion. Okay, there is the, okay, in the beginning I told you have to maintain one formula book in your notebook. Last page, try to write all the formulas. Okay, daily 1 time, 2 times you have to go through those formulas. Okay, that is going to help you lot in the during your exam preparation. Okay, so I wish all of you all the very best. So do your best, and if you want any help from my side, I'm ready to do. Okay, if you have any doubt at any point of time, you can contact me, you can approach me, so I will be there. Okay, then moreover this one, if you have any feedback, you can give me feedback. I'm ready to accept. Yes, whether you, I don't know whether you understood or no, 100%. Initially, आपको थोड़ा ये problem हो जाएगा. So by the time you might have adjusted with me, and I have adjusted with you. Yes, if you have any feedback, you can give it to me. Yes, can anyone give me the feedback? Anyone? Yes, from the offline people. Okay, see, you may be identifying me every day. Okay, so whenever I meet you, but I cannot recognize you because you are in the online. But the people who are sitting in the classes, there are 15 to 20 students. I can easily recognize and I can easily talk with them. But I cannot talk with the remaining people who are there in the online. Whenever you come to the college, whenever you meet me, okay, we will have the conversation at that time. But I cannot recognize you. You have to remind me and you have to talk with me. Okay, is it fine, all of you?
Yes, sir.
Only okay. Among this one, I heard only 3-4 people. That is Shivanjali and some more, Madhura, I think, and Noor. 3-4 students have given good responses, and rest of the students have not at all spoke. Na? Prajakta, Santoshi, Shivani, Aditya, Nikita, Shweta, Vikram, Samir, Vivek has in touch. Okay, Kunal has also given. Mangesh, Dhaneshwar, Rahul. See, there are so many students. Okay, but here there are so many friends. Okay, I can speak with these people. Yes, wait 1 minute. Before closing this one, I want some feedback from your side. Okay, either it may be positive or wait. I will just a minute.